Hello everyone, and welcome. In this video, we'll be diving into the world of Power BI, focusing specifically on one of the most important concepts, DAX Part 2. This session is brought to you by ZoomInData, your space for learning business intelligence and data analytics. So, let's get started and understand how Power BI connects to different data sources and why this process is so essential in today's data-driven world. First question: what is a date table in Power BI, and why is it required for time intelligence functions? A date table is a table that contains a continuous sequence of dates, with columns such as year, month, quarter, week, and day. It covers the complete time range of the dataset. Time intelligence functions like year-to-date, month-to-date, quarter-to-date, and same period last year need a proper date sequence to work correctly. If dates are missing or irregular, these functions can return incorrect results. The date table must also be marked as a date table in Power BI. This allows DAX to recognize the calendar and apply time-based calculations properly. With a date table in place, functions like total year-to-date or dates in period work smoothly and update automatically as new dates are added. Second question: what is the difference between same period last year, date add, and parallel period? Same period last year returns the same range of dates from 1 year earlier. It is designed only for year-over-year comparisons. Date ADD is more flexible. It can shift a set of dates by any number of days, months, quarters, or years. This makes it useful for rolling calculations like rolling 12 months or rolling 3 months. Parallel period also shifts dates by months, quarters, or years, but it ignores the exact day-level context. It works more at the month or quarter level. The key difference is this: date ADD is granular and works with any time interval. Same period last year only handles a 1-year shift. Parallel period works at higher levels and ignores the specific days. Use date ADD for rolling windows, use same period last year for simple year-over-year, and use parallel period for month or quarter comparisons. Third question: why do time intelligence functions fail without a continuous date column? Functions like total YTD, same period last year, dates in period, need sequential, uninterrupted dates to calculate periods accurately. Missing dates in the fact table can cause these functions to return blank values or incorrect aggregations. Continuous date table ensures all days, months, quarters, and years are present for accurate calculations. Best practice: use Calendar or Calendar Auto to generate a complete date table and mark it as a date table in Power BI. Fourth question: what is the difference between YTD, MTD, and QTD calculations in DAX? Year-to-date aggregates values from the start of the year to the current date. Month-to-date aggregates values from the start of the current month to the current date. Quarter-to-date aggregates values from the start of the current quarter to the current date. Used for performance tracking over standard time periods. Example: comparing current month sales to MTD, or this year's sales to YTD. DAX functions: total YTD, total MTD, total QTD, simplify these calculations using the date table. Fifth question: how does dates between differ from dates in period? Dates between returns all dates between a fixed start and end date. Ideal for custom period calculations. Dates in period returns dates for a dynamic period relative to an anchor date, for example last 30, 60, 90 days. Dates in period is dynamic, commonly used for rolling analysis, while dates between is static, custom. Both are used inside Calculate to filter measures over specific periods. Example: dates between, date, 2025, 1, date, 2025, 3/31. Calculates sales for Q1 2025. Sixth question. Write a DAX measure to calculate last month sales using date add. Last month sales is equal to calculate sum of sales, amount, date, add, date, -1, month, date add, shifts the date context by -1 month. Calculate applies this filter to aggregate sales, amount, requires a continuous date table, updates dynamically as new data is added. Seventh question. Create a measure to calculate rolling 90-day sales using dates in period. Rolling 90-day sales is equal to calculate sum, sales, amount, dates in period, date, max, date, -90, day, dates in period, returns the last 90 days relative to the latest date in context. Useful for analyzing recent trends. Works dynamically as data updates without manual changes. Eighth question. Write a measure to calculate sales for the latest month dynamically max date. This measure calculates the sales for the latest month in the dataset. It first finds the most recent date using the max function. Then it filters the date table to keep only the dates that belong to the same year and the same month as that latest date. Finally, it adds up the sales amount for that filtered month. This is useful when showing the current month's performance on a dashboard. Uses max, date, to identify the latest date. Filter ensures only the latest month is considered. Useful for dashboards showing current month performance. Ninth question. Write a year-over-year growth percentage measure without using the same period last year function. To calculate the year-over-year growth percentage, use the dateAdd function to shift the date context back by 1 year. First, calculate the current year sales. Next, calculate the previous year's sales by shifting the date back 1 year. Finally, subtract last year's sales from the current year's sales, and divide the difference by last year's sales. This returns the year-over-year growth percentage. This method is useful when the same period last year function cannot be used or when more flexibility is needed in the calculation. Write a custom date range sales measure using the dates between function. The dates between function is used when sales need to be calculated for a fixed start date and a fixed end date. It returns all the dates between those 2 points, which makes it perfect for custom time periods. To build this calculation, first define a measure that sums the sales amount. Then, apply the dates between function by giving it a start date and an end date. For example, choosing the 1st of January 2025 up to the 31st of March 2025 will calculate sales only for the first quarter of that year. This method is static and precise, and it is commonly used in management reports where a specific date range must always be shown. 11th question. What is the difference between if, switch, and switch true? The if function checks a single condition and returns one value if the condition is true and another value if the condition is false. It is suitable for simple, binary decisions. The switch function compares a given expression against multiple specific values and returns the corresponding result. It is useful for handling multiple discrete categories. Switch true evaluates multiple logical conditions sequentially and returns the result of the first condition that evaluates to true. This approach allows you to define ranges or complex conditions in a cleaner way than nested if statements. 12th question. Why should format not be used for numeric logic? The format function converts numeric values into text. Once a number is converted to text, it cannot be used in arithmetic or numeric calculations directly. Using formatted numbers in calculations may lead to errors or unexpected results because the underlying value is no longer numeric. Safe usage. Format should only be used for displaying numbers in visuals, labels, or tooltips, not for calculations. Example: format, sales, amount, 0, 0, is appropriate for showing numbers with commas in a chart, but cannot be used in a sum, or average, calculation. 13th question. Explain the difference between the concatenate function and the concatenate_x function. The concatenate function is used to join only two text values together. It cannot combine an entire column or multiple rows. It is meant for simple, one-to-one text merging. The concatenate_x function is more powerful. It loops through a table or a column and joins many values into one single text string. A separator, such as a comma or a hyphen, can also be added between the values. This makes concatenate_x useful for creating lists or summaries. For example, it can create a comma-separated list of all product names purchased by a customer. In short, concatenate joins two text values. Concatenate_x joins many values and can include a separator. 14th question. What is the search function used for in DAX? The search function is used to find the position of one text inside another text. It tells the starting position where the word or phrase appears. If the text is not found, it normally gives an error. So it is often used together with the IFERROR function to avoid the error and return a safer result. The search function is not case sensitive. That means it treats uppercase and lowercase letters as the same. This makes it useful for text analysis. For example, using search with the phrase gmail.com on an email column can help find users who have Gmail accounts. 15th question. When should the IFERROR function be used in DAX? The IFERROR function is used when a calculation may produce an error. This can happen during division by zero, missing data, or incorrect text searches. The function has two parts, the main expression and the fallback value. If the main expression fails, the fallback value is returned instead. Using the IFERROR function keeps the report clean. It prevents error messages from appearing in visuals and replaces them with a safe value. For example, writing IFERROR sales amount divided by sales quantity, 0, will return 0 if the quantity is 0. 16th question. What are common logical functions in DAX and when should they be used? Logical functions are used when there is a need to check multiple conditions in a calculation. Common logical functions include AND, OR, and NOT. These functions can be combined with if or switch statements to create complex conditional logic. Using logical functions helps to categorize data, create key performance indicators, or set flags in reports. For example, Writing if and sales amount greater than 5,000 and sales region equals West, then high else low will categorize sales as high or low based on the amount and the region. 17th question. How do text functions help in data cleaning or transformation in DAX? Text functions are used to manipulate and clean string data for analysis. Common text functions include left, right, mid, trim, and substitute. These functions are useful for removing unwanted characters, extracting specific parts of text, or formatting names, emails, or product codes. Text functions can also be combined with logical functions to dynamically classify or filter data. For example, writing substitute product code empty will remove all hyphens from product codes, preparing them for analysis or for matching with other tables. 18th question. How can customers be categorized into gold, silver, and bronze using switch in DAX? The switch function is used to evaluate conditions one by one and return the first result that is true. It allows dynamic segmentation of customers based on sales thresholds. Using switch is cleaner and easier to maintain compared to multiple nested if statements. For example, writing customer segment equals switch true customers total sales greater than 100,000 then gold customers total sales greater than 50,000 then silver else bronze will categorize customers into gold, silver, or bronze based on their total sales. 19th question. How can the domain name be extracted from an email column in DAX? Text functions like write, len, and find are used to extract parts of text from an email. The find function locates the position of the @ symbol in the email address. The write function then extracts all the text after the @ symbol, giving the domain name. This is useful for grouping or filtering users based on their email provider. For example, writing email domain equals write users email, len users email minus find @ symbol users email will return the domain name from each email address. 20th question. How can hyphens be removed from a text column using substitute in DAX? The substitute function is used to replace specific characters in a text column with another value. This is useful for cleaning and formatting data. For example, writing clean product code equals substitute products code, empty will replace all hyphens with nothing, effectively removing them. This method is simple and effective and can be extended to remove multiple characters by nesting substitute functions. 21st question. What is the difference between SUM, average, SUMX, and AVERAGEX in DAX? The sum function adds all numeric values in a single column and is very fast, but it cannot handle row-level expressions or logic across multiple columns. The average function calculates the simple mean of all values in a column but cannot compute averages of calculated expressions like profit divided by cost per row. The SUMX function works row by row through a table, evaluates an expression for each row, such as quantity multiplied by unit price, and then adds all the results. It is ideal for financial and transactional models. The AverageX function also works row by row but returns the average of the evaluated expression. It is useful for calculated metrics like margin percentage, order level averages, and conversion rates. For example, writing total revenue equals SUMX orders quantity multiplied by unit price will calculate the total revenue by multiplying quantity and unit price for each row and then adding them. 22nd question. How does calculate perform context transition? Calculate converts row context into filter context, enabling measures to be evaluated using the current row values. This allows expressions inside calculated columns or iterators to behave as aggregated measures within a modified filter context. Calculate changes the environment in which calculations are performed, making it possible to override, add, or remove filters. Context transition is essential when performing advanced calculations that depend on both row-level and filter-level behavior. 23rd question. What is the difference between ALL, all selected, and all except? All removes all filters applied on a table or column, enabling calculations such as grand totals or percent of total across the entire dataset. All selected removes filters but still respects the user's external selections like slices, making it ideal for interactive dashboards. All except clears all filters except the specified columns, allowing group-level calculations such as region-wise ranking. These functions differ in how much filter context they keep or remove, and are essential for controlling calculation scope. 24th question. Why is filter considered a row-by-row iterator? Filter evaluates the logical condition one row at a time, checking whether each row meets the given criteria. Only rows that return a true result are included in the filtered table, making it selective but computationally heavier. Since it introduces row context, filter allows deep, condition-based evaluation but is slower than non-iterative functions. Filter is commonly used inside Calculate to apply customized filtering logic such as sales greater than 50,000. 25th question. Explain the relationship between values and rank X. Values returns a distinct list of items in a column, ensuring rank X works with unique entries instead of duplicates. Rank X uses this filtered, distinct list to assign ranking positions based on a measure such as total sales. Without values, the ranking function might treat duplicated rows as separate entries, causing inaccurate ranks. Values is often combined with rank X to create clean, reliable ranking logic across products, customers, or regions. 26th question. How is average X used for advanced calculations? Average X iterates over a table and computes an expression for each row before calculating the average, useful when averaging calculated metrics rather than raw numbers. It enables advanced scenarios such as computing average profit percentage, conversion rate, or order level margins. Simple average cannot evaluate expressions like profit or sales for every row, but average X can. This function is widely used in KPI dashboards for more accurate statistical and performance insights. 27th question. Why is sum X preferred over sum for calculated fact table metrics? Sum X evaluates expressions per row, giving more accurate results when values must be computed dynamically. It supports complex logic such as discounts, taxes, and conditional calculations that are not stored directly in the dataset. Sum cannot handle expressions across multiple columns and only aggregates existing column values. Sum X offers greater flexibility for financial, sales, and operational models where row-level calculation precision is required. 28th question. How can a profit measure be written using sum X in DAX to multiply quantity by unit price? The sum X function goes row by row through a table and evaluates an expression for each row. It multiplies quantity by unit price at the row level, ensuring accurate line item calculations. After evaluating each row, SUMX adds all the results together to generate the total profit. It is the standard and most accurate method for financial calculations that require per-row computations. For example, writing profit equals SUMX sales quantity multiplied by sales unit price will calculate the total profit by multiplying quantity and unit price for each row and then summing all the results. 29th question. How can a measure be created to calculate the percentage of total sales using all in DAX? The all function removes all filters from a table to compute the overall total sales. A measure can divide each row's sales amount by the grand total to calculate the percentage contribution. This helps to analyze performance across products, regions, or categories. It is commonly used in dashboards for key performance indicators, market share visuals, or contribution charts. For example, writing % of total sales equals divide sum sales amount, calculate sum sales amount, all sales will calculate the percentage of total sales for each row. 30th question. How can products be ranked within each region using rank X and all except in DAX? The all except function removes all filters except for the region, allowing ranking within each region. The rank X function assigns rank numbers based on each product's total sales in descending order. This helps to identify top-performing products for every region separately. It is commonly used to build leaderboards, perform competition analysis, and create region-wise comparison visuals. For example, writing product rank by region equals rank X all except sales region, total sales, blank, descending will rank the products within each region based on the total sales. 31st question. What is the difference between blank and zero in Power BI? The blank function represents missing or unavailable data, similar to null in databases. It indicates that no value exists in the data model. Zero is a valid numeric value and participates in all mathematical and statistical calculations. It indicates that a value is known and it is zero. Power BI automatically hides blank values in visuals, removing clutter, while zero will always appear and affect axis scaling and totals. Using zero instead of blank can change the business meaning. For example, blank means no sale recorded, but zero means sale recorded but the amount is zero. Treating both the same can lead to inaccurate key performance indicators, wrong averages, misleading trends, and incorrect financial interpretation. 32nd question. How does coalesce simplify replacing missing values in DAX? The coalesce function checks multiple expressions and returns the first non-blank value, making it efficient for replacing missing data. It avoids lengthy nested if statements, resulting in cleaner, more readable, and maintainable DAX code. Coalesce allows flexible fallback options, including numbers, text, measures, or calculated values, improving error handling. For example, writing coalesce sales, 0 ensures that missing sales values do not break calculations such as division or percentages. It is widely used in dashboards for scenarios like falling back to the last known value or showing A instead of blank. 33rd question. Why do visuals ignore blank values but not zero values? Power BI treats blank as non-existent, so charts do not plot a point for it, and tables hide it unless forced to show. Zero is treated as actual numeric data, so visuals include it in bars, lines, totals, data labels, trend lines, etc. This helps maintain a cleaner visualization, preventing misleading empty points where data simply isn't available. Blank ensures that incomplete or irrelevant data does not distort patterns, especially in line charts or KPIs. This behavior is important because treating blank as zero could create false dips, false lows, or broken performance metrics. 34th question. How do blank values affect average, count, and sum calculations? Sum ignores blank values, adding only valid numeric entries, which prevents errors but may underrepresent missing data. Average divides by the count of non-blank values, making the average artificially high if many blanks exist. Count ignores blank, but counter counts non-blank text and numeric values, important when dealing with mixed data types. Blank values can lead to incorrect interpretations where missing entries look like good performance. Understanding blank behavior is crucial for accurate KPIs, especially in financial, operational, and customer-based metrics. 35th question. When is it better to keep blank instead of replacing it with zero? When zero would incorrectly imply activity, for example, blank revenue means no transaction, but zero revenue means transaction happened with zero amount. When you want visuals to hide unwanted or incomplete data, keeping blank prevents clutter and misinterpretation. In financial models, blank often preserves data integrity, indicating missing or unrecorded values rather than real zero values. When performing percentage or ratio calculations, blank prevents false denominator values, reducing divide by zero risks. Keeping blank helps maintain cleaner trend charts, avoiding misleading drops and artificial flat lines. 36th question. Why can replacing blank with zero cause misleading insights? Zero creates a false numeric representation, suggesting an actual recorded event instead of missing information. It can inflate or deflate KPIs such as average sales, margin percentage, or customer conversions due to incorrect denominator or numerator values. Visuals may show fake dips or patterns, misleading decision makers into thinking performance declined. Zero values may propagate into time intelligence calculations, creating unnatural breaks or misleading MOM or YOY changes. Business users may make decisions assuming the zeros are real numbers, leading to wrong strategic conclusions. 37th question. Why is handling blanks important in financial and sales dashboards? Dashboards rely heavily on accuracy, and handling blank values ensures that key performance indicators like margin percentage, year-over-year growth, and churn reflect real business performance. Many DAX functions, such as SUMX, AVERAGEX, divide, and filter, treat blank values specially, so improper handling can lead to unexpected or incorrect outputs. Blank values also interact with relationships, filters, and time intelligence, which can affect totals, running totals, rolling averages, and trend lines. Poor handling of blanks can result in wrong trends, distorted insights, and misleading comparisons, especially in sales, finance, and forecasting. Proper blank management ensures clean reports, more reliable decisions, and consistent behavior across measures. 38th question. How can a DAX measure be written to return the last non-blank sales value? The last non-blank value function scans a column, such as the date column, from the latest to the earliest and returns the most recent value where sales is not blank. This is useful for dashboards that need to show the latest available sales instead of displaying blank values for missing days. It also helps in real-time reporting when data arrives with delays, for example, daily sales not yet updated. This measure is often used in key performance indicators such as last updated sales, latest stock level, or last transaction amount. For example, writing last non-blank sales equals calculate last non-blank value date total sales, all date will return the most recent sales value that is not blank. 39th question. How can a DAX measure be written to identify missing dates in a date column? The measure uses the ISBLANK function to check whether sales exist for each date. It flags date gaps as missing when there is no sales data and marks dates as available when data exists. This helps to detect holes in time series data, which is common in daily or weekly financial reports. It is also useful for validating the date table and ensuring that the data has complete granularity. Missing dates can then be highlighted in visuals, tables, or with conditional formatting to make gaps easy to spot. For example, writing missing dates flag equals if is blank total sales, then missing else available will flag each date as missing or available based on sales data. 40th question. How can a DAX measure be written to return no data if both sales and profit are blank? The measure uses the ISBLANK function to check whether both total sales and total profit are blank. If both are blank, it returns no data. Otherwise, it returns available. This measure checks two metrics at once to identify rows where all key values are missing. It is useful in scenarios where a product or region has not recorded any transactions. Using this measure helps to create cleaner tables by explicitly marking missing data instead of showing blank values. It also supports better troubleshooting of incomplete datasets and ETL issues. For example, writing sales profit check equals if is blank total sales and is blank total profit, then no data else available will flag rows where both sales and profit are missing. Thank you for watching this session. If you have any questions, you are welcome to contact ZoomInData through our website, email, or phone. We're always here to support your learning journey. See you in the next video.